Hello students, let's do playing with numbers exercise 3.4, and in this exercise we're going to be doing co-primes. Exercise 3.4, question 5, which of the following numbers are co-prime? Now what are co-prime numbers? Now we'll do it with the help of this question itself. We'll try and understand what co-prime numbers are. So we've been given two numbers 18 and 35. Now we have to find the factors of these numbers. So first we're going to find the factors of 18. So let's find the factors of 18. Now how do we find the factors of 18? These are numbers that multiply to give us 18. So 1 into 18 is 18. Then we know 2 into 9 we know is 18. Then let's go on to 3. So that will be 3 into what? 3 sixes are 18. So 3 into 6. Then 4, no, 4 into nothing will give us 18. 5 also. Then we have 6. 6 threes are 18, but we already have 6. So that's it. So these are the factors of 18. So what are they? They are 1, 2, 3. Then let's go this way. 6, 9 and 18. So let's write down the factors of 18. 1, 2, 3, 6, 9 and 18. These are the factors of 18. So we've finished with 18. Let's find the factors of 35. So here again 1 into 35 is 35. Now what else will give us 35? 5 sevens are 35, isn't it? 5 sevens are 35. Will there be any other numbers that will give us 35? No, that's it. So 1, 5, 7 and 35. So let's write that down. These are the factors. 1, 5, 7 and 35 are the factors of 35. Now common factors. What are the common factors? Let's look for factors that are there both in 18 and 35. So 1 is a common factor. So let's write down 1. And is there any other common factor? Now we can't see any other common factors. We don't have 2 here, 3, 6, 9, 18. No, because here the numbers are 5, 7 and 35. So we don't have any more common factors. The only common factor is 1. So numbers like these, like 18 and 35, which have only 1 as their common factor, such numbers are called co-primes. So this is the meaning of co-prime. What are co-prime numbers? Co-prime numbers are numbers like 18 and 35 which have only 1 as a common factor. They don't have any other common factor between them. Okay, so this 18 and 35 are co-prime numbers. So since a common factor is 1, the numbers 18 and 35 are co-prime. So the main question is, which of the following numbers are co-prime? And we've been given many numbers. The first one is 18 and 35. So 18 and 35 are co-prime numbers we found out. Let's go on to the next one. Next one is 15 and 37. Are these co-prime? So for this, the first thing we need to do is find the factors of these two numbers. So let's find the factors of 15. Starting with 1. 1 into 15 is 15. Then let's go on to 2. Will 2 into anything give us 15? No, 2 into nothing will give us 15. What are the numbers that will give us 15? 3. 3 fives are 15. 3 into 5 is 15. Will anything else give us 15? No, nothing else. So what are the factors of 15? 1, 3, 5 and 15. So let's write that down. 1, 3, 5 and 15 are the factors of 15. Now let's go on to the next number, that is 37. Let's find the factors of 37 beginning with 1. 1 into 37 is 37. What are the other numbers that will give us 37? Nothing else, because 37 is a prime number. That means the factors of a prime number will be only 1 and itself. So what are the factors of 37? 1 and 37. Now, what are the common factors? There's only one common factor, that is 1. As you can see, only 1 is common to both. We have 1 as a factor of 15 and we have 1 as a factor of 37. No other factor is common. So since 1 is the only common factor, 15 and 37 are also co-prime numbers. So since a common factor is 1, the numbers 15 and 37 are co-prime. They don't have any other factor common to both of them. Next one is 30 and 415. Now let's find the factors of 30, beginning with 1. 1 into 30 is 30. 2, yes, 2 into 15 will give us 30. What about 3? 3 into 10. 3 tens are 30, isn't it? 4, no. 5, yes. 5 into 6. 5 sixes are 30. 6 fives are 30. 6 is already there. So we've got the factors of 30. 1, 2, 3, 5, 6, 10, 15 and 30. These are the factors of 30. Let's write it down. 1, 2, 3, 5. Then we have 6, 10, 15 and 30. These are the factors of 30. So now let's find the factors of 415. So that's a big number, isn't it? So let's start with 1. 1 into 415 will give us 415. What about 2? Okay, now we can use the tests of divisibility that we learned. Now, is this number divisible by 2? No, because the last number is not an even number, the last digit. Okay, so it's not divisible by 2. Is it divisible by 3? What is the test for 3? So we take 415. What is the test for 3 to know if this number is divisible by 3? We have to add up 4 plus 1 plus 5. How much is this? 4 plus 1 is 5. 5 plus 5 is 10. And 10 is not in the tables of 3. So this is not divisible by 3. Is 415 divisible by 4? We have to take the last two digits, 1 and 5. 15, is that there in the tables of 4? No, it's not there in the tables of 4. So it's not divisible by 4 also. Is it divisible by 5? Yes, it's divisible by 5 because the last digit is 5. So let's divide 415 by 5 and see. So 415 divided by 5. Let's take 41. 5 eighths are 40 minus 1. Bring down 5. Now the number is 15. 5 threes are 15 minus 0. So if your remainder is 0, that means that number is divisible. So 5 into 83. 83 will give us 415. Now, is 415 divisible by any other number? Since it's ending in 5, let's see whether it's divisible by 15 or 25, numbers ending in 5, which can give us 415. So let's just try and see whether this is divisible by, say, 15. We finished with 5. So let's take numbers ending in 5 as the divisor, just to check whether 415 is divisible by that number. So after 5, let's take 15 and see. So let's divide 415 by 15. Okay, 15 ones are 15, 15 twos are 30 minus, now here we have 1, 1 and 5. 15 into what will give us 115 or a number close to it. So if I take the tables of 15, now let's do 15 into 7. Okay, because we're looking for a number ending in 5. 7 fives are 35, carry 3, 7 ones are 7, 8, 9, 10, 105. So suppose I write that 15 sevens are 105 and my remainder will be 10. It's not 0. That means 415 is not divisible by 15. Okay, so 415 is not divisible by 15. Now what are we doing here? We are trying to see if 415 is divisible by any other number. So far we got 1 and 5, 5 into 83. Now 15 we checked, it's not divisible by 15. Now let's take the next number ending in 5 after 15. That will be 25, isn't it? Now why are we taking these numbers ending in 5? Because 415 is also ending in 5. Isn't it? That's why we're doing it. So now let's divide 415 by 25 and see. Okay, 25 ones are 25, 25 twos are 50. So we can only take 25 ones here. So we'll do that and let's subtract and see what we get. So here 3 and 11. 11 minus 5 is 6. 3 minus 1 is 3 minus 2 is 1 and 565. So now we have to multiply 25 by a number and get something close to 165. Let's try with 6. 6 5s are 30, carry 3. 6 2s are 12, plus 3 is 15, 150. And 150 can be written here. So let's write 25 6s are 150. Now when you subtract, again you're not getting the remainder 0. So it's not divisible by 25 also. So when you try different numbers, you will see that 415 is not divisible by any other number. So these are the only factors of 415. And what are they? 1, 5, 83 and 415. So let's write that 1, 5, 83 and 415. These are the only factors of 415. Now what are the common factors here? Again, let's check and see. So we have 1 that's common. Then 2, we don't have 2 here. 3, we don't have. 5 is common. So can you see? 5 is also common. Nothing else is common. So let's write down the factors of the common factors of 30 and 415. 1 and 5 are the common factors. So these two numbers 30 and 415 have two common factors 1 and 5. So they are not co-prime numbers. If they are co-prime, they'll have only one factor and that will be 1. So since the common factors are 1 and 5, the numbers 30 and 415 are not co-prime numbers. Question D, 17 and 68. So first let's find the factors of 17. So let's begin with 1. 1 into 17 is 17. Now 17 is a prime number, so we have only two factors, 1 and itself. So 1 and 17. Now let's find the factors of 68. So starting with 1, 1 into 68 is 68. You can go to 2 because 68 is an even number. Now 2 into what is 68? Let's divide 68 by 2 and see. 2 3s are 6 minus 0, 8. 2 4s are 8 minus 0. So 2 into 34. 2 into 34 is 68. Now let's try with 3. Is 68 divisible by 3? Let's do the test. 6 plus 8 is 14 and 14 is not in the tables of 3. That means 68 is not divisible by 3. So now we can go on to 4. Let's see if 68 is divisible by 4. Let's divide it and see. 4 ones are 4 minus 6 minus 4 is 2. Bring down 8. The number is 28. 4 sevens are 28. And the remainder is 0. That means 68 is divisible by 4. That is 4 into 17 is 68. So that's it. No other numbers will give us 68. So these are the factors 1, 2, 4, 17, 34 and 68. So the factors of 68, let's write 1, 2, 4. Then we have 17, 34 and 68. Now we need to look for the common factors. So 1 is common to both. You can see 1 for 17 and 1 for 68. Now what about 17? 17 is also common to both. So now what are the factors of 17 and 68? The common factors are 1 and 17. So now as you can see, there are two common factors. So these two numbers are not co-prime numbers. Remember, if they are co-prime, they should have only one common factor and that should be 1. So since the common factors are 1 and 17, the numbers 17 and 68 are not co-prime. Next one. So here we have 216. So let's first find the factors of 216. So let's begin with 1. 1 into 216 is 216. Now 216 is an even number, so we can divide it by 2. Let's divide and see. 216 divided by 2. 2 ones are 2 minus 0. Bring down 1. 1 is smaller, so we put a 0 and we bring the next number. 16. 2 8s are 16 minus 0. So what do we have here? 108. 2 into 108 is 216. Now, is 216 divisible by 3? Let's do the test and see. 2 plus 1 plus 6. 2 plus 1 is 3. 3 plus 6 is 9. Yes, it's divisible. So 216 is divisible by 3. So let's do the division and find out what is the other number. So 3 will not go in 2. So 21 3 sevens are 21 minus 6 3 twos are 6 minus 0. So 3 into 72. 3 into 72 is 216. Okay, so we finished with 1, 2 and 3. Now let's go to 4. Is the number 216 divisible by 4? So what is the test for 4? You take the last two digits. Now you have 16. Is that there in the tables of 4? Yes, 4 fours are 16. So 216 is divisible by 4. So let's do the division and find the other number 4 into what? So let's take 21. 4 fives are 20 minus 1 and bring down 6. 4 fours are 16. So we found that 4 into 54. Okay, let's write it down. 4 into 54 will give us 216. Is the number 216 divisible by 5? It's not divisible, isn't it? Because the digit in the ones place should be 0 or 5 if it has to be divisible by 5. So this is not divisible by 5. Is it divisible by 6? This number is divisible by 6 if it is divisible by 2 and 3. And here we can see it's divisible by 2 and by 3. So let's do long division and find out 6 into what will give us 216. So let's begin with 21. 6 threes are 18 minus, so here we minus 11 minus 8 is 3, bring down 6. 36. 6 sixes are 36. So what have we got here? 6 into 36. So let's write that. 6 into 36 will give us 216. Now is 216 divisible by 7? We can try that and see. Okay, so 7 twos are 14, 7 threes are 21, minus, we have 6. 6 doesn't go in 7, so 0. So the remainder is 6. So 216 is not divisible by 7. Now is it divisible by 8? Okay, so let's check and see whether this is divisible by 8. So 8, now let's take 21. 8 twos are 16 minus, so when you minus here, you get 11 minus 6, which is 5, and bring down the next number, 56. Now 8 sevens are 56, and the remainder is 0. That means 216 is divisible by 8. 8 into 27. So let's write that. 8 into 27 is 216. Now is 216 divisible by 9? Let's do the test for 9. 2 plus 1 plus 6. 2 plus 1 is 3. 3 plus 6 is 9. Yes, 9 is divisible by 9, isn't it? So let's divide 216 by 9 and see. 9 twos are 18. We can write that here. 9 twos are 18 minus borrow. So here it is 11 minus 8. That is 3. Bring down 6. Now 36. 9 fours are 36. And the remainder is 0. So 9 into 24. 9 into 24 is 216. So as you can see, 216 has many factors. We'll continue to check. So we did with 1, 2, 3, 4. We checked 5, 6, 7, 8, 9. We checked with 7 also. Now let's go to 10. Now 216, is it divisible by 10? No. If it is divisible, the last digit should be 0. Okay, now is this divisible by 11? Let's check and see. Take 216. Is this divisible by 11? So remember the test for 11? Check the digits in which place they are. So this is 1, 2, 3. These are the places. So let's take the digits in the odd places. Odd means the first place and the third place. Let's add it up. 6 plus 2 is 8. And then take the digit in the even place. That is 1. So here it is 1. Now subtract the 2. 8 minus 1. What do we get? 7. Now if it is divisible by 11, this will be 0. Or it will be a multiple of 11, like 11, 22, 33. So this is not divisible by 11. Now let's take 12. 216. Is it divisible by 12? If it is divisible by 3 and 4. Now here let's see, it's divisible by 3 and by 4. So it's divisible by 12. 3 fours are 12. So let's divide and see. So 12 ones are 12, 12 twos are 24. So I can only say 12 ones are 12 minus, now here we have 11. 11 minus 2 is 9 and bring down 6, 96. Now 12 into 8. 8 twos are 16, carry 1. 8 ones are 8 plus 1, 9. 12 eights are 96 minus 0. So here what do we have? 12 into 18. So let's write that down. 12 into 18 is 216. Okay, then the next number will be 18. So 18 is already there, isn't it? 18 into 12, it's already there. So that's it. We don't have any more factors of 216. So what are all the factors of 216? 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 27, 36, 54, 72, 108 and 216. We have many factors there. Let's write it down. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 27, 36, 54, 72, 108 and 216. Now let's go on to the factors of 215. We have to find the factors of 215. So beginning with 1, 1 into 215 is 215. Now 215 will only be divisible by a number ending in 5, isn't it? So let's try with 5. 215, let's divide this by 5. 21 if I take, I can say 5 fours are 20 minus, I get 1, bring down 5, I have 15. 5 threes are 15 minus 0. So 5 into 43. 5 into 43 is 215. Now you can also check with other numbers ending in 5 to see whether it's divisible, whether 215 is divisible by that. But you will see that these are the only factors of 215. That is 1, 5, 43 and 215. So let's write it down. 1, 5, 43 and 215 are the factors of 215. Now what are the common factors? Let's look for the common factors. We have 1 that is common. Now let's look for 5. We have 5 here. Do we have 5 there? We don't have 5. We have 43 here. Do we have 43 there? We don't have. We have 215 here. Do we have 215 there? No. So the only common factor here is 1. So since the common factor is 1, the numbers 216 and 215 are co-prime numbers. Question F, 81 and 16. So now let's find the factors of 81 first. So factors of 81, we begin with 1. Always begin with 1. 1 into 81 is 81. Now 81 is not an even number, so it's not divisible by 2. Is it divisible by 3? 81 is 81 divisible by 3. Let's add and see. 8 plus 1 is 9. Yes. Since the answer is 9, the sum is 9. 9 is in the tables of 3. That means 81 is divisible by 3. So let's divide 81 by 3 and see. 3 twos are 6 minus 2, bring down 1, 21. 3 sevens are 21. So, and the remainder is 0. That means 3 into 27. Let's write that. 3 into 27 is 81. Now, what are the numbers when multiplied give us 81? What about 9? 9 nines are 81, isn't it? 9 nines are 81. So that's it. We don't have any more factors for 81. So what are the factors? 1, 3, 9. You don't have to repeat 9. So 27 and 81. Let's write that. So that is 1, 3, 9, 27 and 81. Now we have to write the factors of 16. So let's begin with 1 again. 1 into 16. 1 into 16 is 16. 16 is an even number, so it's divisible by 2. 2 eights are 16. What else will give us 16? 4, isn't it? 4 fours are 16. That's it. These are the factors of 16. So what are those? 1, 2, 4. You don't have to repeat 4 again. 8 and 16. So let's write that. So that's 1, 2, 4, 8 and 16. These are the factors of 16. Now what are the common factors? Let's look and see. So we have 1 is common. Now 3, we don't have 3 here. 9, we don't have 9 here. 27, no. 81, no. So the only common factor here is 1. And since 1 is the only common factor, 81 and 16 are co-prime numbers. So since the common factor is 1, the numbers 81 and 16 are co-prime numbers. So now we have found out which are the numbers that are co-prime and which are the ones that are not co-prime. Question 6. A number is divisible by both 5 and 12. By which other number will that number always be divisible? So there is a number here. We don't know which number that is, but it says it is divisible by both 5 and 12. Okay, that means we need to look up the factors of 5 and 12. So let's see that. So first, let's consider this number, this unknown number. Let's consider it to be x. Now let's find the factors of 5. So beginning with 1, 5s are 5. That's all. Nothing else would give us 5. So the factors of 5 are 1 and 5. Then let's find the factors of 12. Beginning with 1. Let's begin with 1. So that will be 1 into 12 is 12. Then let's go to 2. 2 6s are 12. Then let's go to 3. 3 4s are 12. That's it. Nothing else will give us 12. So what are all the factors of 12? 1, 2, 3, 4, 6 and 12. Let's write that down. 1, 2, 3, 4, 6 and 12. So this number x that we have, we said let the number be x, that is going to be divisible by all these numbers. It will be divisible by 1, it will be divisible by 5, again 2, 3, 4, 6 and 12. It will be divisible by all these factors. Okay, now let's take a number. Let's try one example. Now if I take say 36. Okay, and I say 36 is divisible by 9 and 4. Okay, 9 4s are 36, isn't it? So let me take the factors of 9. 1 9s are 9 and 3 3s are 9. So 1, 3 and 9 are the factors of 9. And 4, what are the factors of 4? 1 4s are 4 and 2 2s are 4. So these are the factors of 4. So what is my example? I've taken a number 36 and I say it is divisible by 9 and by 4. So what did I do? I took the factors of 9 and I have the factors of 4. Now if you look at all these factors, can you see that 36 is divisible by all these numbers? 36 is divisible by 1. 1 into 36 is 36. 36 is divisible by 3. 12 3s are 36. It is divisible by 9. 9 4s are 36. Now let's go to the factors of 4. It is divisible by 1. 1 into 36 is 36. What about 2? 2 into 18 is 36. What about 4? 4 into 9 is 36. That means this number 36, if I say that it is divisible by 9 and 4, it is also divisible by the factors of 9 and the factors of 4. Now, it is also divisible by 9 fours, the product of 9 and 4. The product of 9 and 4 is 36. It is divisible also by 36. So did you understand? So I've taken this example 36 and I'm telling you that it's divisible by 9 and 4. Just like this question 5 and 12, I say that it's divisible by 9 and 4. If I say that, I need to take all the factors of 9, all the factors of 4, and you can see all these numbers will divide 36 completely. Also, when I multiply 9 into 4, I get 36. So 36 also will divide 36 completely. Similarly here, all these numbers will be able to divide this number completely. That means give a remainder 0. Also, if I multiply 5 into 12, that means the product of 5 and 12. 5 12s are 60. When you multiply, you will get 60. That means all the numbers that can divide this number, this unknown number completely will be all these factors and 60. So let's write that down. The numbers by which x will be divisible is, so let's write down all the factors of 5 first, 1 and 5. And all the factors of 12, let's not repeat 1. So 2, 3, 4, 6, 12. And let's write the product of 5 and 12, that is 60. So these are all the numbers that can divide the unknown number completely. Question 7. A number is divisible by 12. By what other numbers will that number be divisible? Now this is simple because we have only one number here. So this number, let us consider that number to be x. Let the number be x. That means x is divisible by 12 is given to us in the question. It is understood that it is also divisible by the factors of 12. So here we have to find all the factors of 12. So let's do that. 1 into 12 is 12. Then we can go to 2. 2 into 6 is 12. Then we can go to 3. 3 fours are 12. So that's all. We have only this many factors for 12. And what are those? 1, 2, 3, 4, 6 and 12. Let's write it down. The factors of 12 are 1, 2, 3, 4, 6 and 12. These are the factors of 12. That means the other numbers by which this number x will be divisible are these numbers. That is 1, 2, 3, 4, 6 and 12. So this number, the unknown number, which is divisible by 12, will also be divisible by all the factors of 12. So with this, children, we come to the end of this exercise. Thank you, children.